Auto reclosers are automatic high-voltage electric switches designed to protect power distribution systems. Similar to circuit breakers in household electrical systems, they shut off electric power when a fault occurs, such as a short circuit. However, unlike household circuit breakers that remain shut off until manually reset, auto reclosers automatically test the electrical line to determine whether the trouble has been removed. If the problem was only temporary, the recloser automatically resets itself and restores electric power. These devices are used throughout the power distribution system, from substations to residential utility poles. They range from small reclosers for use on single-phase power lines to larger three-phase reclosers used in substations and on high-voltage power lines up to 38,000 volts. Standards for reclosers are defined by ANSI/IEEE C37.60. Importance of auto reclosers in power systems. Auto reclosers are recognized by electric utilities worldwide as essential devices for achieving their prime goal, providing maximum continuity of electric service to customers simply and economically. Their importance in power systems can be summarized through several key benefits. 1. Improved power supply reliability. Auto reclosers sense and interrupt fault currents and automatically restore service after a momentary outage. Since most line faults, 80 to 90%, are transient, the auto recloser can quickly restore power, preventing prolonged outages. 2. Reduced outage losses. By minimizing outage duration, auto reclosers significantly reduce economic losses for both utilities and consumers. For single-fed radial lines, this is particularly valuable as it prevents extended periods without power. 3. Enhanced power system transient stability. The use of automatic circuit reclosers on high-voltage transmission lines reduces system oscillations caused by short-circuit faults, thereby improving the stability of parallel operation and increasing the transmission capacity of the lines. 4. Grid construction investment savings. In power grid design and construction, considering the role of reclosers can, in certain situations, defer the need to build double circuit lines, thus saving substantial investment. 5. Correction of false trips. Auto reclosers can correct false trips caused by faulty circuit breaker mechanisms or protective relay malfunctions, further ensuring power supply continuity. 6. Ensuring industrial production. For critical industrial equipment that would lead to plant shutdown if power is lost, such as boiler feed pumps, fuel pumps, or fans, auto reclosers ensure rapid power restoration after temporary faults, preventing disruptions to normal production. How auto reclosers work. Basic principles. The working principle of auto reclosers is based on their intelligent management and restoration capabilities within power lines. Their core function cleverly utilizes the transient nature of power line faults. 1. Fault detection. When a line experiences a transient fault, e.g., due to a lightning strike or foreign objects blown by wind, the protective relaying system immediately issues a command to quickly cut off power, causing the circuit breaker to trip and isolate the fault. 2. Dead time. The recloser waits for a very short dead time, typically 0.15 to 0.5 seconds. This interval is sufficient for the arc at the fault point to extinguish ionized particles in the air to dissipate, and the line's insulation performance to naturally recover. 3. Automatic reclose attempt. After the waiting period, the recloser controller issues another command to attempt to automatically close the circuit breaker, restoring power to the line. 4. Result evaluation. If the line successfully recovers, it means the fault was indeed transient, and power supply is quickly restored without manual intervention. However, if the fault is permanent, e.g., a fallen pole, broken line, the recloser's first attempt will fail, and the protective relay will trip again. 5. Lockout. In cases of permanent faults, the recloser device enters a lockout state, discontinuing further reclosing attempts and awaiting maintenance personnel intervention. This intelligent mechanism effectively distinguishes between transient and permanent faults, avoiding repeated stress on equipment due to persistent faults while maximizing power supply continuity. Types of auto reclosers by design and operation. Auto recloser types by number of phases. Based on the number of phases they control, auto reclosers can be classified into three main types. 1. Single-phase reclosers. These are used to protect single-phase lines such as branches or taps of a three-phase feeder. They can also be used on three-phase circuits where the load is predominantly single-phase. When a permanent phase-to-ground fault occurs, one phase can be locked out while service is maintained to the remaining two-thirds of the system. Due to their lighter weight compared to larger three-phase reclosers, single-phase reclosers are typically mounted directly to the pole or substation steel structure individually by the built-in mounting hanger bracket. 2. Three-phase reclosers. These are used on three-phase circuits to improve system reliability and where lockout of all three phases is required for any permanent fault, to prevent single-phasing of three-phase loads such as large three-phase motors. The mode of operation is typically three-phase trip and three-phase lockout, where all contacts open simultaneously for each trip operation. The three phases are mechanically linked together for tripping and reclosing, operated by a common mechanism. 3. Triple single reclosers. These are electronically controlled and have three modes of operation. Three-phase trip and three-phase lockout. All three phases simultaneously trip on an overcurrent, reclose, and sequence together. Single-phase trip and three-phase lockout. Each phase operates independently for overcurrent tripping and reclosing. If any phase sequences to lockout condition, due to permanent fault, or if lockout is locally or remotely asserted, the other two phases trip open and lock out. Single-phase trip and single-phase lockout. Each individual phase trips and sequences to lockout independent of each other. This is primarily for residential loads and/or where single-phasing of three-phase loads is protected by other means. Auto recloser types by power source configuration. Based on the power system structure and configuration, reclosers can be categorized as 1. Single-source feeder lines. These typically only require a standard three-phase single-shot recloser. The configuration is simpler as there's only one power source to consider during reclosing operations. 2. Dual-source feeder lines. These require synchronous check reclosers to address synchronization issues between the two power sources. The recloser must ensure no voltage verification and synchronization verification before closing, ensuring safe operation when multiple sources are present.